also change the color. Now block it. So this is AP1. You mirror this point and it's going to be the other side, so mirror it in mainframe. So it's all done. Assalamu alaikum, welcome to CAD Tutorial BD. I am Mahadi Hasan. Today I'll show you how we draw the steel frame in AutoCAD. So here is the main beam layout, the main beam layout, steel main beam layout, and here is the main beam schedule. Schedule of steel main beam and the beam size and the flange thickness here. So this is the information for draw the main beam. Now there is the sub beam layout plan, and we use sub beam in our frame. And here is the tie beam layout plan, and in the bottom there is a tie beam information and schedule. And the next there's a rafter layout plan for our rooftop shed, and it's equally divided by three part for its size. And here is the rafter schedule, rafter size, thickness, flange wave thickness, size here. So this is the Polyline layout plan. In above the rafter we use the Polyline for our sheeting. So this is the Polyline, C Polyline layout plan, and the bottom there is the Polyline information. C Polyline 150 and the thickness 2 mm. Here is the size 50/20 and thickness 2 mm. And this is the plate layout plan, the Polyline plate we use for the joint with rafter. So this is the plate detail. And here is the sheeting layout plan, roof sheeting. This is only a simple drawing, and it's mentioned the slope of our steel shed. And here is the information for our floor height. Our first floor height 3600 millimeter, and second floor height 3000 millimeter clear height, the rafter bottom to our floor. This is the clear height. So let's go, we draw our frame. First of all, we need our steel column layout for Rcc column layout for our drawing. So we copy the Rcc column layout in the other side where we draw our frame. So first we copy the our Rcc column layout. So select CO, enter, copy, and place the other side. And now we rotate the plan clockwise. Okay, rotate. Okay, arrow, enter, rotate, and its place. Okay, now we need to construction line for the location of our column. So XL, enter, and V, enter for vertical line. So now we place the point of our column. Okay, we select the point, place our vertical line. Okay, now we give a horizontal construction line. XL, enter, H, enter, we use. Now we just change the layer. Now we this is the part of column we continue in above beside of our steel column, because for our sidewall. Now we offset it 300 millimeter because our Rcc column is up to 300 millimeter up to plinth level. So we offset it. Now we trim the other line, that's not need. So trim, we use the trim command, tr double enter, trim all the line, that's we not need, unneedable line. Okay, trim the one line, sorry. Okay, trim and match properties. Okay, we prepare all the RCC column. So we trim all the line, that's not need. Okay, now our RCC column is ready for the section. Now we set the base plate and steel column here. So we need to the base plate layout plan. So we copy the base plate layout plan, CO enter, and place it in our place and rotate it clockwise. And we need to a reference line, so X construction line in a midpoint, so we place it in the right place. Okay, now we again we need to the construction line and the point of our steel column and the base plate. So construction line, XL enter, B enter, and give the point of steel column and the base plate. Now change the color for the base plate line. This is the base plate line, the green color, and copy all the other column and the base plate, because our column size is similar, so we not need to point another point, we just copy this line. Okay, okay, now we're going to our section, and we need to the base plate thickness, so we need this information. Now we're going to the base plate detail, where we find the base plate thickness. So here is the base plate detail. So the base plate thickness is 16 mm. So we're going to our section and offset 16 mm, O enter, 16 enter. Now this is the base plate thickness. Now we draw the base plate line, so rectangular, REC enter, and draw a rectangular here, delete the line, offset line. Okay, trim our column line in bottom, change the layer, base plate. Okay, delete the other line. Okay, here's the base plate. So now we need to give the anchor bolt symbol here, where the anchor bolt placed. This is the column line, steel column line, and this is the side RCC wall column, RCC column. So we change the color, blue color. Now we change all the RCC section color by blue. Okay, now we need to the anchor bolt position, so we're going to the layout and give the point of the anchor bolt. Okay, here is the anchor bolt point. So again we need construction line, use construction line and give the point. Now we draw a bolt position, so we just offset it by the regular hole of our anchor. Now this is a symbolic point, so no need to draw the anchor here, main anchor here. So we just need to locate the point. So this is the symbolic anchor bolt section. So just change the layer. Layer is the very important because you need to draw the wall drawing in the different layer for your help in future. So just copy it, the other point. Okay, this is the anchor bolt and the base plate section. So we need to place all those our column and steel column. So because of our steel column size is same, so we just copy all the column and the base plate in all this point. So we just select our base plate column and copy and give all this by copy, set every point. Delete the line. So we find our column and base plate. Now we're going to the beam layout and copy all the beam detail and layout and place it, copy, CO enter, use, and now just give the point, reference point, rotate this clockwise, arrow enter, select the wall layout and place it the middle reference line. Okay, now we find the position of our main beam. Here is the main beam, and we need to the main beam size for draw. Okay, now our floor height is the 3600 millimeter. So you offset it, O enter, 3600 millimeter offset for our floor, and this is the floor position, and offset it 100 because our floor thickness is 100 millimeter deck slab. So we offset 100 millimeter. And now we need to the main beam size for the section. So we're going to the information drawing, I mean the main beam schedule in the B side of here. Okay, just we rotate it 400 and 400, wave thickness 400, so we offset 400. Okay, for our help we just rotate this actual distance and place it. Okay, now we see the right angle 400 millimeter, so we offset 400, O enter, 400 enter. Okay, and the flange thickness 8 mm, so we see the flange thickness. Okay, O enter, 8 enter. Okay, offset into side. Now we change the layer, we give it the main beam layout, main beam layer. Okay, and color change, so we find out easily. Now we give the end plate section because the connection plate, beam and column, so we give it 16 mm thickness plate here, so we just offset the 16 mm, so enter, 16 mm enter. Okay, now we give the bolt in the outer side of beam, so we give 100 millimeter offset and just rectangular Rcc enter and change the layer plate, joint plate. Okay, delete the wall other line, helping line. Okay, now trim the inner side line of beam because it's not continue. So this is the joint plate, and now we give the bolt here, I mean the bolt position. So we draw a construction line in middle part. We need to the clear space to hold to the inner side of beam is minimum 30 to 35. So we this information we just place the bolt here, CO enter, copy. Okay, now we just mirror its first copy the middle point, copy it to the middle point. Okay, now select and mirror, MI enter. Okay, now the joint plate and the section is joint bolt section done. So we just place it in the other place, the other point. Every point we need to the joint. So copy the plate and CO enter. Just mirror, use the mirror command. Now again we use the mirror. Okay, now we trim the middle line of the beam and set all the plate in every point. Now we draw the sub beam section. So we first of all we need to know the sub beam size. The sub beam size is 300 millimeter. So again 300 for 156. I mean wave 300, thickness 4 milli, flange thickness 150, and thickness 6 mm. So we draw a I section here, cross I section here. So we draw the cross I section for our information. Okay, our sub beam cross section done. Now we change the layer by sub beam layer. Okay, it's done. Now we give the plate and joint plate. So first rectangular draw, RCC enter, and stretch by 15 mm in the outer side, and this is pin connection. So we give the bolt in the middle of our sub beam. So now we draw the bolt. So now the bolt size, and we draw the bolt plan here. So we use the offset and construction line for draw the bolt. Okay, now we just use the circle command, C enter. Okay, draw a circle. Now delete all the line. Now we draw the construction line, two construction line in the middle of our circle. Now we draw another circle here. Use the offset command. Okay, and now trim all the other point. Okay, delete the line. So this is the bolt, and we change the layer. First of all, bolt layer, and also change the color. Now block it. Use the mirror, mi enter. Okay, in the middle point. Now again mirror mi enter and copy it in the middle part. Okay, now we block it, block and change the layer, subbeam layer. Okay, now we copy this to place our section. Now we need to the point where we set the subbeam, so we give the construction line in the point of middle point of our subbeam. Okay, now we place it. You must know about that the wall beam top surface is going to the same line, so we give a construction line for our beam, main beam, top of the main beam, for set up the position of subbeam. So now we move it. Okay, move it in the point. Now we copy all this point. Okay, copy all this. Okay, now delete the line. Now we set a rectangular for our floor. Okay, and delete the other. This is the floor, so we just give it the, change the layer, and now we has the portion, give the RCC hatch, concrete hatch. Okay, now we change the hatch properties, concrete hatch. Okay, and now change the layer in the hatch layer. Okay, our floor is done. So our first floor level is complete. Now we going to the draw our, sorry, we need to draw the tie beam, give the tie beam here. So we delete the subbeam position and give the tie beam position here. So we give all the point. Now we need to draw the tie beam and its joint properties. So tie beam size here. Now we copy the subbeam. Okay, and explode, delete the wall other part, and edit the size. Okay, stress and give the tie beam size. Okay, we change this by tie beam size. Okay, change the layer, and now we give it we join tie beam to main beam by cleat. So we need to draw the cleat here. So cleat is one kind of plate to joint, one kind of joint plate. We just place it to the main beam and tie beam connection. So we draw a cleat here. Okay, now we draw a rectangular for our cleat plate, Rcc enter. Okay, 2 point, delete all the line, change the layer of our plate. Now we give the bolt point, we give it 3 bolt. Okay, done. So now block it, B enter, change the layer. Now copy it to the point, typing point, copy and set the point, set at the point. Okay, every point of tie beam. Okay, that's done. Now delete all the line. So our first floor level is complete, so we draw our rafter detail, I mean the rooftop shade above the first floor. So now we need to the clear height 300 millimeter. So now we just draw a rectangle construction line here and just offset it by 300 millimeter. Okay, draw a construction line and offset it, O enter, 300 millimeter. Okay, now we give the end plate at the top of our column for set the rafter and column joint. So offset it by 16 mm for our end plate, and the inner side 15 mm and the outer side 100 millimeter extend in our plate. And first of all we just cut our RCC column in the for the boundary wall. So just we set up the position of our column height and trim the column line above on it. So just trim it and the mesh properties here. Okay, and copy it the other side and just trim it. So our RCC column end here, side column, and now we just offset it 100 millimeter for the outer side of our column. So give a rectangular RCC enter to rectangular, draw and change the layer base plate. So this is the end plate of our section. Now trim it and delete all the line. Okay, so this is the end plate, and now we check the height 300 millimeter. Okay, in the middle part of two base plate, two end plate to our floor. Now we need to draw the rafter. First of all we need a slope for our rafter, so we give the 1:10 slope here. So draw a line, slope line. Okay, first need 1000, 100 and set it. Okay, now we need the slope line, delete all other line and place the slope line into our position. And now we just give the middle line of our building, this called ridge line. Now we set it, and now we extend the line to the ridge line. Select this and EX enter and give the position. So our slope is okay. Now we change the layer, and now we need the information for our rafter size. Okay, so we copy the rafter layout, rotate it clockwise, and place it at the middle point, reference point. Now here is the rafter change position, rafter 1, 2 and 3 size. So we place the position point by the construction line and set the schedule here. That's we find easily. So first we need to the size of rafter 1. Okay, we offset it rafter 1 size and extend the line to above to plate, and then again we need to just extend the line. Okay, so our rafter size 600 to 650. So we just offset the flange size, the middle part. Now we set the angular point for the cutting of our rafter. So delete the line, now offset it by our needable middle part, the middle part size, and trim the other two line. Here the other point, so we just draw a angular line here, angular construction line, select two angular construction line and trim the middle part, and also the other side. Okay, now we just select and extend S-enter stress and join the two line. Okay, this is the tapered section. So we check the size here, 450, and check the size, yes, 450 rafter 2. Now we extend the line. Okay, set a construction line at the top of the ridge line. Okay, top of the ridge, and copy it by 600, because this point rafter is tapered by 600 millimeter, 650 millimeter. So trim the line and extend stress to the and join the point, delete the line. Delete the straight line. Okay, we find out the tapered section, and now we just place the bolt here. So we just extend the line because of support of our rafter. So trim the flange. Okay, trim tier enter, double enter. Okay, now we just place the cleat for our rafter and column. Draw the cleat here. Change the layer to the cleat layer. Okay, done. And give another plate here for support. It's called stiffener, so give another stiffener here, stiffener plate. So our part is complete. Now we give the plate here, joint plate, rafter to rafter joint plate here. Okay, use polyline for draw the angular plate. Okay, done. Change the layer. Okay, delete all the part. And now we use to bolt section here, so we copy the bolt section and place here. Rotate. Okay, copy and set the bolt section also here. Align AL, double enter. Okay, set the bolt section. Now copy this because the joint plate is similar, so we copy the joint plate to the other point where the section is changed. So trim, delete all the other line and trim the middle line. Here double enter, use. Okay, now we just cut our middle column here. We not need the middle line. It's in at the first floor level. Okay, done. So rafter draw is complete. Now we just here we need to the end plate because the column is end to the rafter bottom, so I need a plate. Just move the plate into the rafter end position. Okay, now we draw a rectangular for our end plate. Delete all the other line and change the layer here. Change the plate layer and delete the other part. No, just delete the other part. So our rafter, now we give it the bolt section. Okay, copy the bolt section and give it the other point. Okay, okay, our rafter drawing is complete. So now we need to set the purlin at the top of our rafter. So we going to the purlin layout and count it. Okay, now we see the rafter purlin detail, I mean the purlin size. Now we draw a purlin here to the actual size. We use the polyline to draw it. Now offset it in 2 mm, the inner offset, and just change the layer first, purlin layer. Okay, our purlin is complete. Now we set up the purlin in the position. Again we count. Okay, now set it here. So now we need the cleat for our purlin cleat joint plate to the rafter. So we draw the cleat here. draw a rectangular and delete all the part. Okay, our keylet is done. Now we change the layer. Now we just need to give a bold detail, bold section, so we copy the bold section for the other side and just place it to our clit, I mean purlin clit. So copy it, block, explode, and copy our bolt. Okay, set the position. Okay, so bolt, place the other two bolt, so one is complete. Now we copy it, two bolt, delete this portion, and now block it, B enter. Okay, block, change the layer. Now we set the purlin to the actual position. First of all, we need to offset to 50mm to the ridge line, so offset it and just place it. And first of place it, we need to align align the angle, so AL enter, use the align command and align the purlin, double enter. Okay, the complete. Now we place it the right position. Okay, now we copy it and place it the end of our rafter. Okay, the end position. Now we draw a line. Draw a line to the middle of and the middle to middle, and now divide it by 10 because we need 11 purlin, so div enter, 10 enter, so we get the point. Now copy it to the every point, divided point. Okay, now delete the line and the point line. Okay, now we need to give the roof sheeting, so draw a construction line, angular construction line, and offset it by 25 and draw a polyline. Delete other part and change the layer, sheeting layer. Okay, the sheeting is complete. Now we need to give the dimension here. So we give the dimension every point. So now we check it the scaling in our viewport, so just scale it and we give the text size, actual text size in our section, so we scale here. So give it the scale. this is the scale, complete scale. Now we going to the change our we need to draw a sidewall, side sheeting. So we give a purlin here after set the dimension, before set the dimension. So we just set here. Okay, here is the purlin, and now we give a construction line and offset it by 25 mm. Okay, now it's the sheeting. So draw a polyline for the outside sheeting, delete it and change the layer, match the layer properties. Okay, so now we give the dimension. Okay, and first of all we just draw a downspout for the rainfall. Okay, now we give the dimension. Okay, set the dimension here. The dimension need to get the every point. Okay, now we give the ridge height. So this is the ridge height. Okay, now with the angular dimension for our rafter size. Now we need to the dimension of our purlin position. So we give the dimension here, purlin to purlin. Okay, now give the continuous line. Okay, now we give to the rafter size, I mean the flange and wave size here for better information. so we give a dimension and edit it to the text. Set a dimension, click, double click here, edit, and we write the flange and wave size here. So the wave size is 1600 to 45 mm into, and we give the thickness, just see the size here, 5. Okay, 5, and its wave size, so we draw wave, right wave here, WEB wave. Okay, now we give another dimension for the flange size. Copy the text, place here, and change the size 210, its flange size, FLANG flange. Okay, now we place the every part where the rafter change. So our rafter detail and done. Now we write a symbol, draw a symbol here. It show the slope detail, and the which slope we draw in the for our rafter, which slope used for our rafter. So copy text, we use 1:10 slope, so this is 10 1 0 1, and here is the 10. So it's okay, done. So our end part is done, and we give the dimension of the floor to floor dimension here. Okay, we set every dimension that need for the construction. Okay, so this is done. Now we just mirrored it, and you also need to locate the point of joint plate. So we draw arrow, ladder, LE enter, and named our joint plate, it's JP1. Okay, JP1, this end plate, so it's EP1, EP2, and we named EP1 the first end plate, so this is EP1, and we also named our first floor plate, so this is JP2, and this is JP3, I mean the joint plate 3. Okay, and the middle we set the copy all these two, it's the cleat CL1, I mean the cleat 1. Okay, okay, now our one part is done. Now we just mirror it to the other side, and it's going to all done, because you need to draw one part, because if the similar two parts, just you mirror this point, and it's going to be the other side. So mirror it, MI enter, select all the part, and MI enter, mirror. Okay, all done. Look, the wall part is complete. So this is easy way to draw similar kind of frame. Okay, so just mirror it, and the all other part is done. And you just need some correction here, but just trim the and delete this part. Okay, delete the middle line. So this is our framing main frame. So it's all done, and now we just the level here, write the level. This is print level, and copy the line in the first floor level. This is the first floor level. First floor level, and give the title, grid title here. Break the line, delete the other part, and just give the title here. We need to give a title here. So this is our framing. So, and just has the RCC part, sidewall. It's need to okay, just has match the has properties. Okay, and just mirror it to the other side. It's help to understand this is the RCC wall, RCC column. So now our frame is done. So just we need to give the title here, the grid title, and which grid we draw here. So the section on grid C. So section on grid C. So this is the steel frame drawing. So I think you understand well, and it's helped you a lot to draw the steel frame and understand the steel frame drawing. So thanks a lot for watching my video. Please comments and share this video, and please subscribe my channel. Thank you. Assalamu alaikum.